Hello, and welcome back to the channel and episode 3 of System Design Fundamentals. Today we're talking about one of the most critical components in any scalable system, load balancing. Think of load balancers as the traffic controllers of your architecture. So, what exactly does a load balancer do? At its core, it intelligently distributes incoming network traffic across multiple servers in your infrastructure. This prevents any single server from becoming overwhelmed with requests, which is absolutely crucial when you're handling thousands or millions of users. The beauty of load balancing is how it drastically improves both the responsiveness and availability of your applications. When traffic spikes, and trust me, it will, your load balancer becomes your first line of defense, ensuring users still experience smooth performance. This technique is particularly essential in systems that use horizontal scaling, which we covered in our last episode. Remember, rather than making one server more powerful, we're distributing work across many servers. Without proper load balancing, horizontal scaling simply doesn't work. It's that fundamental to maintaining uptime, ensuring fault tolerance, and achieving true scalability in modern systems. Now, let's talk about how load balancers actually make their routing decisions. There are several algorithms they can use, and choosing the right one for your specific workload makes all the difference. The simplest approach is round robin, where requests are distributed to servers in a rotating, sequential order. Server 1 gets the first request, server 2 gets the second, and so on until we cycle back to the beginning. It's straightforward but doesn't account for server capacity or current load. A more intelligent approach is the least connections method. Here, new requests are sent to whichever server currently has the fewest active connections or sessions. This works wonderfully for situations where requests can vary significantly in how long they take to process. Then we have IP hashing, which uses the client's IP address to consistently route requests to the same backend server. This is crucial for maintaining session state, like keeping a user logged in or preserving items in a shopping cart. Each of these methods has its place depending on your application's requirements. The key is balancing load effectively without sacrificing either performance or consistency, sometimes a tricky trade-off. Let's go a bit deeper and talk about the OSI network model and how it affects load balancing. Specifically, we need to understand the difference between Layer 4 and Layer 7 load balancers. Layer 4 balancers operate at the transport level, working with TCP and UDP protocols. They make routing decisions based on network information like IP addresses and ports, without inspecting the actual content of packets. This makes them extremely fast, but somewhat limited in their decision-making capability. Layer 7 balancers, on the other hand, work at the application level. They understand HTTP and HTTPS protocols and can make sophisticated routing decisions based on things like URL paths, types of content, HTTP headers, and even cookies. This intelligence comes at the cost of slightly higher processing overhead. Here's an easy way to remember the difference. Layer 4 is all about raw performance, while Layer 7 is about intelligent traffic handling. When should you choose each? Go with Layer 7 when you need complex routing, like directing API requests to one set of servers and web page requests to another. Choose Layer 4 when you need maximum speed and your distribution needs are relatively simple. Now, let's get practical and look at some real-world load balancing tools you can implement in your systems today. NGINX is one of the most popular open-source solutions out there. Originally created as a web server, it's now widely used as both an HTTP server and reverse proxy. It supports both Layer 4 and Layer 7 load balancing and is known for its high performance and stability. HAProxy is another powerful option. It's a dedicated high-performance TCP/HTTP load balancer that's trusted in production environments worldwide. Its reliability under extreme loads has made it a favorite for mission-critical applications. If you're in the AWS ecosystem, Elastic Load Balancer, ELB, offers integrated load balancing that works seamlessly with their auto-scaling groups. It handles the heavy lifting of scaling your load balancing capability alongside your application servers. Which should you choose? Consider your cloud provider, the type of traffic you're handling, and how much configuration control you need. The good news is that all of these support essential features like health checks to detect failed servers, failover mechanisms, and SSL termination to offload encryption work from your application servers. Let's put everything together with a real-world example that many of you might relate to, an online exam portal. Imagine you're responsible for a university's exam system. On exam day, you'll have over 100,000 students trying to log in within minutes of the exam opening. Without proper load balancing, your system would collapse under this traffic surge. Here's how load balancing solves this. As students flood in, the load balancer distributes their connections across your pool of exam servers. No single server gets overwhelmed, and students experience consistent performance regardless of when they log in. The load balancer continuously performs health checks on each server. If one starts failing or becomes unresponsive, it's automatically removed from the pool, and traffic is rerouted to healthy servers, all without students noticing any disruption. Since maintaining exam state is critical, we can't have students losing their progress. We'd implement sticky sessions using IP hash. This ensures each student remains connected to the same server throughout their exam, preserving their work. This approach prevents any single point of overload and ensures a fair distribution of the processing burden across your infrastructure. Exactly what you need when failure simply isn't an option. Wrapping up the episode 3 with this, in the next one we will have a look at caching. So don't forget to be there. Before you go, I'd love to hear from you in the comments. If you found this video helpful, to give it a like, share it with your friends, and of course don't forget to subscribe to the channel to help us grow. I will see you in the next one. Till then, happy learning.